Today we'll discuss the low-level design of a food delivery system like Swiggy or Zomato. We'll start with discussing the system design on Whiteboard. Then we'll look at the detailed UML diagram that I have made. We'll be discussing the relationship between the classes and the details of the classes as well. And then we will look at the entire code as well. So whatever we are going to discuss today, I have designed the system myself. Obviously, there can be multiple approaches of solving the same system. So at various points, I'll be talking about the alternative approaches possible, and I'll also discuss my assumptions, what I could have done better, or things that I have not taken care of. So without any further delay, let's get started. Let's start thinking from what exactly happens when a customer places an order in an app like Swiggy or Zomato. So we are receiving an order. Now this is a food order. So whenever we receive this order, we have to take care of two major things. One thing is that we have to start preparing the food. We have to tell the correct restaurant that exactly this is the food that you need to start preparing. The other thing that we need to take care of is delivery. So by the time this food is being prepared, we have to make sure that a delivery partner is assigned and the delivery partner reaches the restaurant as soon as possible and is able to pick up the food from the correct restaurant and deliver to the correct customer's location. Here what I'm trying to essentially do is divide our entire big system into small subsystems. Now one subsystem will take care of the food part, and not just the part after receiving the order. I mean that even before receiving the order, the food subsystem should take care of showing the correct menus of the restaurants, what all restaurants are present nearby, and then what all food is available, is it serving currently or not, and things like that. And the delivery subsystem is obviously going to take care of assigning the delivery partner, making sure that they reach on time, and everything related to delivery. And now that we have discussed that we will be dividing our system into two subsystems, the food subsystem and the delivery subsystem, we should also have some connecting point that, okay, what is going to connect the delivery subsystem and the food subsystem? Obviously is going to be order. So our order is going to be received, and the question that you could start thinking yourself is that exactly which class will be responsible for receiving the orders and for telling that, okay, now delivery subsystem has to start taking care of delivery and food subsystem has to start taking care of food part. So we will have an order manager. Now what all is the responsibility of the order manager? First thing is that it will be receiving the orders. Now when it receives the order, it will be generating an order ID. And same order ID should be sent to delivery subsystem also and the food subsystem also to stitch the entire thing together. Other than generating the order ID, order manager will also be responsible to tell the delivery manager that this is your job, this is the order ID, and you have to deliver from this location to this location. Similarly, it will also tell the food manager that this is the restaurant and the restaurant has to start preparing exactly this food in this quantity. So now if you think about it, think about the details. First thing that I said, order ID will be sent to both delivery manager and food manager. But if you think about it, the other data that is sent to delivery manager and food manager is going to be different. Why is that? Think about it logically. So our delivery subsystem should not come to know exactly food items are there in the order if that is how we want to design a system. And similarly, our restaurants or our food subsystem should not bother about where the food is going to be delivered, who is our customer, right? So basically our order manager will receive the entire order details that this user has placed this order, it has to be prepared by this restaurant and all the things. But order manager will make sure that whatever details are required by delivery manager, only those details are sent to delivery manager, and whatever details are required by food manager, only those details are sent to the food manager. Now when we discuss this, you should also be thinking that the data that I might want to send to the delivery manager might change over time. Let me give an example. For example, we start the system by just telling the delivery manager that you have to deliver from this location to this location. Now, suppose after some time we decide that, this delivery subsystem is basically responsible for assigning the correct delivery partners also. Now our system has become huge and we want to assign the correct delivery partner, say on the basis of the rating of customer or on the basis of rating of delivery partners, or how much amount of food is there. If there is a lot of food, then probably a particular kind of delivery partner will be assigned. If there is less amount of food, probably the delivery partner can deliver multiple orders together, things like that. So we have to also design a system such that the amount of data that we send to the delivery manager as well as the food manager might change over time. Similarly, while passing data from order manager to the food subsystem, initially we might decide that we are going to tell only that this restaurant is supposed to prepare this much food. But for example, we also want to tell that, okay, this is the customer's information, and you could probably call the customer and to the customer for feedback or something like that. So the data that we send to the food subsystem might also vary over time. My point over here is that try to make your system as extendable as possible. Your requirements might change, your system decisions might change. Today you might send some particular information to delivery subsystem, and you might want to send some more information day after tomorrow. Every system is going to be continuously evolving, and it is our responsibility to make sure we design it such that it is as extendable as possible. Now we are going to start looking at the design of these subsystems in detail. But before we do that, I would just like to quickly thank you, because the HLD course that I did, that was the first full-fledged course, and it was awesome. Almost everyone from HLD course has signed up for the LLD course, and that itself shows their feedback. And so I received so many great testimonials. I could actually see the difference between their first class and their last class. So it was great, and thank you so much for all the love and support. I am really grateful to be able to do this full time, to be able to teach, and especially now that system design is into consideration, I am more closer to software engineering than I have honestly ever been, because now I get to explore everything just so much in detail. And now I just wanted to say that if you were someone who did not sign up for HLD but you are interested for LLD, do consider it, because it is starting on 19 September. Firstly, it is completely live. So a lot of free content is available. This is available. Our Uber Ola video is there. Zerodha Live is there. Design Patterns is there. There's a lot of free content available on the channel that is there. But if you want to learn in a more structured way, compact way, be consistent, be part of a community, be involved in discussions, then live courses are just awesome. And especially being part of the community, not just during the course, after the course and the discussions, I have seen the difference during the HID course. So if you're interested, all the details with week-wise curriculum and what all things I will be covering in detail is mentioned in keertipurswanicourses.com. Check out the FAQ section. They separate FAQ section for LLD, for HLD. All the details are mentioned over here. If interested, do check it out. And we are starting on 19th September, 5-week course. I hope to see you in the class. But for now, let's get back to our Swiggy Zomato. Let's just start looking at the food subsystem first. So our order manager is going to send the request to the food manager that you have to start preparing food. So this is going to be one class, and the function that is going to be there inside is prepare food. What all things will be passed inside this? Obviously the order ID, the restaurant ID that needs to start preparing, and also it's basically a map that exactly what dish and what is the quantity of each dish. So basically a map of, say, dish and the quantity, so an integer. So this needs to be passed to the food manager by the order manager, telling that you need to start preparing the food. Now there are a few questions that you need to start thinking about or start questioning yourself, that when we talk about the map dish to the quantity, now what does a dish actually mean? You have to start thinking about it. For example, suppose I have ordered from Subway. Now I can be customizing my subs in a particular way, right? Suppose I have ordered paneer tikka. Now I have two different basically add-ons or something like that in the sub. Now is it going to be two different dishes, or is it going to be one dish and the quantity is going to be two? Now these are the details that you need to start thinking, that what does a dish mean, what does a dish add-on mean, and according to that we'll be starting to make our classes. But for now, let's start to think that when the prepare food request comes, now this request from food manager is supposed to go to the correct restaurant with the restaurant ID, right? But how will the food manager come to know that what exactly restaurant needs to start preparing the food? So this is our restaurant, and this restaurant is supposed to start preparing the food. But food manager should come to know that where this restaurant is, which is this object that needs to start preparing the food, correct? So basically what I'm trying to say is that there should be another class which will be responsible for managing all the restaurants, so that we know that exactly which object is corresponding to which restaurant. So obviously, I guess a lot of you have already understood there is going to be a restaurant manager. So this restaurant manager will be responsible for what? It will be responsible for giving us that, okay, for this restaurant ID, this is the object. So it will have basically a map that, okay, for this restaurant ID, This is the restaurant object. Correct? Now, in this restaurant, there are going to be multiple things like menu, location. Is the restaurant available? Because restaurant might not be available at some times. Now, there might be like usual timings of the restaurant, but the restaurant should also be able to set that, okay, I'm available or I'm not available. Maybe some construction is going on. Maybe there were too many orders and I want to stop taking orders currently, or anything like that. Obviously, there's going to be restaurant owners also who is going to make sure that only they can change the availability of restaurants, or any admin things that they have to do, only they can do it. Now, another question that you should be having right now, that suppose there are two Domino's or two Subways. Now, are those two Domino's or two Subways the same object or different objects? Let me give an example. So, there is a Domino's in Sarjapur and there is a Domino's in Marthahalli. So, is there two different objects for those two Domino's, or is it the same object? Now, this is a question that you should be thinking yourself. But if you think about the properties of the restaurant, you're going to store the location, the restaurant owner, and this is going to be separate for every branch of the Domino's. Now, another thing that you could have done is probably do a restaurant chain. Like inside the restaurant, there could have been a flag that what kind of restaurant it is. Like, for example, is it a cafe? Is it part of a restaurant chain or something like that? And if it's part of a chain, you could have like an ID that it is part of this restaurant chain. Similarly, if there's a chain of cafes, you could, like, for example, CCD or Third Wave Coffee. In that cases, you could add like a ID that, okay, this is part of this chain, but for this particular object, this is the owner and this is the location. So you could start thinking of this, but especially in an interview or while designing a system, you have to draw a line somewhere. So what I decided over here is that I am just going to keep different objects for every restaurant. So basically different object for every Domino's branch, because I'm going to have owner, location and all the details inside it. And I'm not taking care of the restaurant chains and all of that. But if you think about it, while creating the restaurants of the same time, you could actually be using factory design pattern, because there you will be creating objects of similar type, right? So if you are getting into that much details, you could use factory design pattern. Another design pattern that you could have started thinking by now is probably for restaurant manager and for food manager. Obviously, I want only one object of restaurant manager to manage all the restaurants, or one object of food manager to take all the food related requests from the order manager. So I have chosen to make restaurant manager and food manager as singleton. Now, it's not necessary that there should be only one object. You could have like a pool of objects that restaurants in this particular area will be taken care by this restaurant manager, or something like that you could do. But again, I have to draw the line somewhere. I'm not going to be getting into that much details, but I'm telling you the alternative approaches to be able to get into details and to be able to design it in that much detail. Now, let's talk about also the part without the order, like when our customer is going to go through the restaurant, should be able to see the menu, whatever food is available. So inside restaurant, there should be a menu. Inside menu, there should be dishes and there should be dish add-on. Now, another question that you should be asking yourself, what does a dish add-on mean? For example, if I say Pepsi or extra cheese or extra dip, is that a dish add-on? Because if that is the case, then we have to make sure that we cannot order just add-ons, right? Because see, now that is the difference between Pepsi and dips. For example, if I'm ordering from a restaurant, I might order just Pepsi or just Coke or basically just cold drinks. Now, do you want to think of it as a dish add-on or not? Because I can order it separately. Should I consider it as a dish or a dish add-on? Versus, according to me, if I think of dish add-ons like cheese dips, extra mayonnaise, sauces, or anything of that kind, I cannot order just cheese or just dip, right? So how I have designed it is that whatever I can order separately, like I can order just cold drink, so I am going to keep it as a dish altogether. Versus the things that I cannot order separately, like cheese dips or extra sauce or whatever, all of that I'm going to keep as dish add-on. So you can add them to a dish, but you cannot order them separately. Now, I can understand that a lot of questions might be coming up right now, like, is Pepsi or is any cold drink really a dish? If you think about it, it will have everything in common other than the ingredients, right? It is going to have an image. It is probably going to have a description, price, all of those things are going to be there. probably dish add-on is not going to be there for, say, cold drinks, correct? Which brings me to yet another case. Say a restaurant has pizzas as well as has Chinese. So there are dish add-ons like cheese and sauces. Now the way you add cheese, like the dish add-on cheese is separate when it comes to pizza and when it comes to, say, any gravy or sauces for noodles, Chinese and all of that. So my point is that the way you add the dish add-on is might also be different for different dishes. So do you want to have dish add-on like at an upper level, at a restaurant level, that okay, there is cheese dip, there are sauces, or you want to keep it within the dishes? Okay, I know it might be getting a bit confusing, but think about all of these questions yourself. So inside restaurant, there is menu. So in menu, you have, say, Chinese menu, North Indian menu, South Indian menu, or something like that, correct? Now, within menu, there are going to be dishes. Now, how I have designed is that I have kept within dishes, there are going to be dish add-ons. So let me just write that down. So within restaurant, there is going to be a menu. Within menu, there is going to be dish. And within dish, there is going to be dish add-on. So again, as I said, so dish add-on cannot be ordered separately, while dish can be ordered separately. And now, okay, now a restaurant has menu, menu has dish, dish has dish add-on. So this is all has a relationship, and we will discuss this in detail when we look at the UML diagram. It's also, but since these are has a relationships, another question that you should be asking yourself while designing: can dish add-on exist without dish? Can dish exist without menu? Can menu exist without restaurant? Now, these are system design decisions that we need to make, correct? According to me, a menu should not exist without restaurant. A dish should not exist without menu. A dish add-on should not exist without a dish. So basically, this is not just has a relationship, but it is also dependent. The life cycle is dependent on it. And that is why this is going to be a composition relationship. So restaurant has menu and menu cannot exist without restaurant. Menu has dish and dish cannot exist without menu. So if there is a, say, cheese and corn pizza, so it is going to be specific to the menu of this restaurant. So say if there is a Domino's Marthahalli and there is a Domino's Sarjapur, each of it is going to have its own menu. Each of it is going to have its own dishes. Now, you could argue that there is a lot of redundant data, and I completely agree with that. That's a good enough point. But if I was asked in an interview, the logical reasoning that I would give is just like a restaurant might be available or not available, like Domino's Sarjapur and Domino's Marthahalli, one might be available, one might not be available. Similarly, dishes can be available at a particular Domino's, might not be available at a particular Domino's, might be available at a particular Subway, might not be available at a particular Subway. So I want to have an availability flag for the dishes as well as for dish add-ons. Maybe I have pizza present, but I don't have extra cheese. I know that would be a terrible restaurant, but could be possible, right? Probably I do not have extra dips left or extra mayonnaise left, and I want to update that. So I should be able to add it that, okay, this dish add-on is not available. It should be able to set the availability of dish add-on and dish. And I wanted to keep the design as simple as possible. So I've kept the relationships very simple, and I have just created different objects for every different instance itself. Like, as I said, depending on location, the menu is going to vary, the dishes is going to vary, the dish add-ons is going to vary. And dish add-on will again be specific for dish and not just for menu. So that is how I have designed the system. As I said, there are multiple ways in which you could do it. There is no right and wrong, but you should be able to give me logical reasoning over here. And I have given you my reasoning. If you have any other reasoning, let me know in the comments and we can discuss it out. Let's quickly look at the flow. When the order manager is going to tell the food manager that you need to start preparing the food manager is going to go to restaurant manager saying that this is the restaurant ID. Please give me the restaurant object corresponding to the ID. Now, this restaurant manager has all the restaurants, right, in this map. So basically, this is also has a relationship. So restaurant manager has all the restaurants. Now, another discussion could be, can restaurant exist without restaurant manager or not? Now, this is again a system decision that you need to make while deciding the requirements itself. Can your restaurants exist without restaurant manager or not? For example, your system has just come up and your restaurant manager has not been made by now till now, and you want to start assigning the restaurants or you want to start creating the restaurants. That could be one way, but I would preferably want that I'm going to create the restaurant manager as soon as my system comes up, and then restaurants can get added. So either this could be aggregation or composition. Now this depends, and you have to discuss with whoever is going to give you the requirements. Menu, as we discussed, that restaurant is going to have menu, so this will be a composition according to what we discussed. Again, this will also be a composition, and this will also be a composition. So food manager goes to restaurant manager, gets the restaurant, goes to restaurant. Now restaurant has menu, dish, add-on and all that, but restaurant is going to start preparing the food and update the status. So restaurant or restaurant owner or admin or whoever it is will be responsible for updating the status of the food, that okay, it is being prepared or it is prepared or whatever. And that also needs to be communicated to our delivery partner, to our customer. So basically there has to be a combined notification service, which will be basically tracking the status of not just the order, the food, also of the delivery partner, and all of these statuses need to be notified, say to customer as well as to multiple people. For example, if delivery partner is coming, probably restaurant also wants to be notified, or if food is ready, then delivery partner also needs to be notified. So notification part is going to be separate, and we will discuss that separately. But for now, let's go to our next subsystem, which is the delivery subsystem. Coming to the delivery subsystem, so now order manager is going to send the request to delivery manager. Now, as we had discussed earlier also, the data that is sent to this delivery manager might change over time. Now, it might change for food manager also, but for demo purposes, I've done it only in the delivery subsystem part, not in the food subsystem part. So basically here, currently what all data that I'm passing: user location, restaurant location, and order ID, correct? Now, currently I am putting these things into another class called delivery metadata. So basically what is going to happen is, when order manager is going to send the request to delivery manager, it is going to send only the delivery metadata, which is basically user location, restaurant location, and order ID as of now. But as we discussed earlier also, we could be sending some extra data like user rating or any other factors based on the which we might have to make delivery decisions. So currently I have put all of these data into delivery metadata. It is basically a wrapper of all the data over there. Now the request that comes to delivery manager is to manage delivery. Now what all things do we have to do to manage delivery? The first obvious thing that comes to our mind is that we have to assign the correct delivery partner. Now this is sort of similar to Uber Ola thing that we did. There we were trying to find correct drivers for our rider. Here we are trying to find correct delivery partners for our customer, right? So here basically, obviously, as you guys must have thought of, that there will be delivery partner manager, there will be delivery partners, but we have to do something to know that, okay, which all delivery partners can do the delivery for this particular order, this order ID, correct? Now, again, think of it just like Uber Ola. Here, if we are in a big city, in suppose Bangalore, Mumbai, there are going to be many delivery partners available. Now, in such cases, we might want to perform delivery based on, say, user rating, or based on the number of deliveries that delivery partner has already done for the day, or rating of the delivery partner, or probably according to the weather conditions, and multiple things like that. Versus, say, I am in a very small city where the delivery partners itself are so less that somehow we just want the nearest delivery partner and just we want to do the delivery. But the system is same only, right? So we will have to write code according to multiple strategies, multiple algorithms to assign delivery partner based on various factors like weather conditions, location, is it tier 1 city, tier 2 city, or things like that, correct? Now, firstly, we have to decide that which strategy will we be using in this particular case for this order ID. So there are different strategies. What are the strategies called? So suppose delivery partner matching strategy. I'm not writing the entire thing. Now there can be different strategies. They can be, say, location based strategy. They could be some rating based strategy. There could be some default one or anything, right? So basically what I'm going to do is create an interface in which, say, a function will be match delivery, and now all of these matching strategies, so they will be location based delivery partner matching strategy, rating based delivery partner matching strategy, whatever it is. So these will basically implement this interface. Why interface? So basically when there's going to be a function, say, match delivery partners, location-based delivery partner matching strategy and rating-based delivery partner matching strategy will be forced to implement match delivery partners. So they will perform the same action but using a different strategy or using a different algorithm. We are basically using the strategy design pattern over here. So yes, the function could be match delivery partners. And what data are we going to pass to this? So we could pass delivery metadata itself. It would be easy. Or even like say delivery manager needs to know more data and this needs to know lesser data. Probably we could create like a subclass of this, another class which will have sub data, like not all the data. Probably another case where we might want delivery manager to know more details, but our strategy classes should not know so many details. So in that case, we could have another class that is being passed over here. But let's not make it so complicated. In very easy terms, currently I'm going to pass delivery metadata itself. And they are going to do what? They are going to match some delivery partners and send us back the list of delivery partners that can be notified, and they will accept that they want to perform the delivery or not. But now we understood that there are different strategies. Now, obviously, there has to be one class that will be responsible for deciding that which strategy are we going to use. So for that, I created another class called strategy manager. So this class is responsible for deciding that which strategy will be used. So basically it will return this delivery partner matching strategy only because it is an interface and these are implementing it, right? So basically it will return this itself, but this will be the one that will decide it, okay, exactly which strategy will we be using. If it's getting a bit confusing right now, don't worry, because we'll look at the UML now and we will look at the detailed code also, so it will be completely clear. But just try to understand in roughly. So delivery manager got the request which had delivery metadata. Based on the same delivery metadata, we are going to use it same everywhere. We are going to send it to strategy manager. Strategy manager is going to use that which matching strategy are we going to use, and then we will get a list of delivery partners and we are going to send the request to these delivery partners. Delivery partner is going to accept and perform the delivery for us, and that is when we are going to update the status of the delivery. So this is the UML diagram that I have made. As you can see, it is like huge. Took a lot of time and effort, but okay, let's get started. I will walk you through it one by one. So as we had discussed, the place where the request is going to come to place the order. So here you can see create order request is coming over here. Order is going to come. So here for now, to make it simple, I have passed the order ID and I've just given some random name, order 1, order 2. But obviously the order ID is supposed to be generated by the order manager. So I will be talking about the assumptions that I have made and the things that I have not taken care of, because obviously it is not possible to design entire Swiggy Zomato, right? So in an 1 hour video or in an interview for that matter. So here you can see there's an orders map. So basically corresponding to order ID, what is the order. Because I've coded in C++, you can see that I've used pointers. But depending on your language, you could just use the objects. That's completely fine. So here you can see there are 2 delivery managers and food managers, right? One thing that we did not discuss while discussing on the board, that with delivery manager and food manager, what will be the kind of relationship? So I have made it composition, as you can see, because order manager has an instance of delivery manager and order manager has an instance of food manager, and they cannot exist without order manager. So these are created as order manager is created. So in the code, you will actually be able to see that in the constructor itself, I'm going to create the food manager and the delivery manager. But then again, that's a system call. Also, another thing to point over here, that in all my managers, I have made them a singleton. How can you know that it is singleton? Firstly, you can see that there's an underline, so it is static. And you can see that I have used a mutex. And the most important thing is that I have made the order manager as private. So these are basically the properties and these are basically the functions. In the functions, order manager, manage delivery, manage food, these are all basically private functions. And these are the public functions. So plus is there. Get order manager. So anyone can get the order manager, but it is static. Why? Because it is always going to return the same instance. What is the instance? The private instance, order manager instance. And we are creating the order. Get order is going to be there corresponding to this order ID, and there is going to map. So there is delivery manager, there is food manager. Let's look at the food manager part first. Again, this is singleton. So there is going to be a private instance. The constructor, as you can see, is again private. Here you can see minus. And the get food manager is basically public and static. And the function that order manager is going to call from here is basically prepare food. that we had seen on whiteboard as well. We had passed order ID, restaurant ID, and the map of dishes, correct? And as we had discussed, it's the same thing as it is. So the food manager is going to go to restaurant manager. The restaurant manager has a map, which is basically restaurant ID and the restaurant pointer. And then there is a restaurant manager instance. And why is all of this there? Because again, restaurant manager is singleton. So why singleton? Here you can see it is private. There is one instance which is again private, and there is and it is also static. The getter is again static, which is always going to return the instance that is there. So basically this instance. So you can add and get restaurant from there. Again, I have used the restaurant name itself as the restaurant ID. I'm not taken care of the restaurant ID and all of that, but I hope you get the point. So food manager is going to go to restaurant manager, get the restaurant. So basically get restaurant. So it is going to pass the restaurant ID, which in our case is the restaurant name itself, and we are going to receive the restaurant pointer. Then it knows that, okay, which is the object now. So it is going to the restaurant, and in restaurant, it is going to say that you need to start preparing the food. This is the order ID and these are the dishes. So as you can see here, I am not telling any user information or any delivery related information or location or anything as such, because what I need to pass to restaurant is just that you need to start preparing this food and nothing else. So here in the restaurant, you can see name, availability, menu, location, owner. Obviously, there will be more things, but these are the main things that I wanted to have. So I've added owner, location. So these are the important factors that differentiate between restaurants. We discussed this in detail, right? That there will be different restaurants for different even branches of Subways or Domino's or whatever. Now, again, as we discussed, restaurant has an instance of menu, and I have designed it such that menu cannot exist without restaurant. So there is composition relationship. Again, menu has dish has dish add-on. We discussed this, all composition relationships. Menu currently has dishes, vector of dishes. Again, a dish is going to have name, description, cuisine, price, all of that. And dish add-on will also have the same thing. So it can have images. Probably want to add image of, say, cheese dip or anything. Price is obviously going to be the description, name, all of that. So this is more or less about the food management part. So here, if you go down, basically all the UML, the code, everything is available on my Git. The link is in the description. So here you can see that there are some things that I have not taken care of, some requirements. So one of those requirements was different menus according to different timings. So currently I have just say one menu. But if you see the relationship between the restaurant and menu, one restaurant could have say multiple menus, say breakfast menu, lunch menu, dinner menu, and things like that. Now, in order to create the menus, you could use, say, factory design pattern, because you're creating similar objects. But for now, I'm not taken care of any of that. I just have one menu. So something that I've not taken care of, you could probably discuss in an interview. Because in an interview, mostly will not be asked to take care of both the subsystems, the food as well as the delivery. You'll be taking care of only one of the two. So you can pick it up in more detail if you have 1 hour and you are taking care of only one subsystem. Coming to the delivery part, so here there is delivery manager. Again, order manager has delivery manager. It is going to say manage delivery. But in this case, I am passing the delivery metadata. So what is there in delivery metadata is user location, restaurant location, and order ID. As we had discussed, we can pass more information inside the metadata itself. Now, some of you might be thinking that I have put order ID in the metadata and I am passing it over here. You are correct. So I need not have to pass order ID separately because it is going to be there in metadata. I just did it. Again, this is demo purposes. Obviously, it can be improved in a much better way, but I'm giving an idea how you would design a system in real scenario or what all things you could improve. Right? Again, delivery manager is singleton. How singleton? See, whenever you have to think of singleton, just see that firstly the constructor is private. Then there is a static instance and there is a static getter. So you are obviously always going to be returning the same instance, and there's a mutex to take care of the multi-threading scenario. Now, another thing that you could be thinking of, that do we really need to take care of multi-threading in delivery manager, order manager, food manager? See, if you do early initializations, basically if you create the instance as soon as the system comes up, then you will never have to take care of multi-threading. Now, as we had discussed, so there's going to be delivery partner matching strategy. We had discussed that it is going to be an interface. So you can see that whenever I add an I or there is this opening closing tags, you can say that it is an interface, and there is match delivery partners. And inside this, I am passing the metadata and I am returning a list of delivery partners. In this case, C++, so vector of delivery partners. I could have used a list as well. And right now, I have just implemented one location-based delivery partner matching strategy, but you get the point. There could be more like rating-based or default or whatever. So they will have to implement this function and they will be returning a list of delivery partners. But as we had discussed, there has to be another class who is going to decide that what strategy are we going to use. So strategy manager is for that. So here you can see what is the work of this strategy manager. It is determining the delivery partner matching strategy. So this is the one that is going to decide which matching strategy are we going to use. So you can see it is returning the delivery partner matching strategy. But the way I've written the code, so basically I'm creating the object over here and returning it. So you can see this as sort of a combination of factory design pattern and strategy design pattern. Why factory? Because I have similar objects and depend like location based and rating based, and I'm creating the object on the basis of delivery metadata. So you could see this as a combination of factory design pattern and strategy design pattern. So here I have some metadata. Again, on the basis of that, I'm deciding. Now, again, as I said earlier, so I am passing the same metadata to the strategy, to the matching strategy, to everything. But you could have different metadata or different wrapper for, say, matching strategy or strategy manager, or like, than the one that we are passing to delivery manager. But to keep things simple, I have done this. So this is more or less what we had discussed. Let's look at the flow once more. So order manager goes to delivery manager. Delivery manager can access delivery metadata because obviously we're passing the delivery metadata. Delivery manager goes to strategy manager. Strategy manager says that, okay, this is your matching strategy. It goes to the matching strategy and then it gets the list of delivery partners. Coming to the delivery partner part, there's one more point that I wanted to discuss. Coming to the users, so there are basically three users. One is our delivery partner, one is our restaurant owner, and one is our client that is going to place the orders. Now, how are restaurant owners and delivery partners different from our customers or our clients? If you see one major difference, these delivery partners and restaurant owners work with us versus customers don't work with us, right? So we don't have to take care of their details. Like, for example, if these are associated with me, if this restaurant is associated with me, or if this delivery partner works for me, I'm supposed to have its KYC. I'm supposed to, basically, it's my partner. So I'm supposed to do more things. So I just wanted to mention that you could probably have another interface. Suppose I partner and delivery partner and restaurant owner could implement them. I have not mentioned too much detail of restaurant owner, but just wanted to bring it to your attention and make you think about it. Like, our customer or client is basically a bit different from our delivery partner or restaurant owner because they work with us and they might have additional things like, receive salary or receive some amount or KYC and things like that. That is why I created another one. And basically also rating. So your rating could be for restaurant as well as for delivery partner. Now you might say rating is going to be for restaurant and not for restaurant owner. It depends. Now again, one restaurant can have multiple restaurant owners also, right? So currently how I made it is as aggregation relationship. So restaurant owners can exist without restaurant. So you're going to register as a restaurant owner and create a restaurant after that. So restaurant owner can exist without restaurant. Now, again, this is a point of discussion. You can argue that first you should be creating the restaurant and then the restaurant owner. In that case, it will be a composition relationship because restaurant will have restaurant owner and restaurant owner will not be able to exist without restaurant. As you can see, as we have discussed in the past also, aggregation versus composition is a very subjective thing and it depends on the design and the requirements, and you can discuss the pros and cons of that. So there are trade-offs in the way you designed, correct? So one restaurant can have multiple restaurant owners, and in that case, you might want the rating to be for restaurant. We have not discussed the feedback system or the rating system in detail, but you get the point that there will be an interface, there will be delivery partner, there will be restaurant owner, and they will be implementing, say, perform KYC or become partner or functions like that. So this is another point that you could do. So this is the code that I have written. So yes, as you can see, it took a lot of effort. And if you appreciate any of the effort and if you have not subscribed yet, please do subscribe. So many people who watch the videos are not subscribed it yet. And it would mean the world to me because it takes a lot of effort. Okay. Continuing, so this is where the code starts. This is the main part. I created Chinese restaurant, South Indian restaurant. and then I created restaurant manager and added the restaurants. Here you can see that I have added the notes that, restaurant owners in this case can exist without the restaurants, because I have first created the owners and then the restaurant and then created the dishes and then the add-ons, and then I have added the menu. So this is not following the composition thing that we had discussed, but this is just for demo, so I just added. Again, restaurant manager I'm creating later and then adding restaurants. So this is again aggregation relationship. So you need to discuss the implications and you need to tell that, okay, this is aggregation, this is composition. Basically, whenever the life cycle is dependent completely, then it will be composition. So I've created some delivery partners also, and I have created some users as well. So 𝐂𝐡𝐞𝐜𝐤, 𝐿𝐴. As I said, again, this is the order ID. Here again, I have mentioned nodes that ID should be created in order manager and all of that. Let's just start looking at this create order. So this is within order manager, right? So let's go to this order manager and let's see what all things are there. So if you see the HPP, so again, the static instance, there is mutex, there is map for the string order. So basically whatever you saw in the UML, it is much more easier once I've seen the UML to convert it into code, because it is the same thing as it is. We saw, okay, there are private instances, there is private. So if you see the order manager constructor, I made it private. And inside the constructor, I'm creating the delivery manager, the food manager. So this is composition relationship, correct? And these are all private ones. And then these are public functions, correct? So this is basically for notification part. Because this is going to be extremely long video, I'm not going to discuss notification part. It is a bit tricky because we have to notify for every order and we have to notify multiple people, and then there can be multiple people who are initiating this. So basically, whenever the status is updated, say the status could be of delivery or of food, the notification needs to be sent to multiple users. So how you would handle this, let me know in the comments that how you would structure your notification service or how you would do. It could be a separate LLD question altogether. But currently, let's focus on the rest of the part. Here, as you can see, so there is manage delivery and manage food. So I've basically divided my system into two subsystems now, right? So when we go inside create order, what all things are there? So let's see. So in manage delivery, what am I doing? I am creating the delivery metadata, and to the delivery manager, I am just passing the metadata and the order ID. As we had said, we could just pass the metadata, no need to pass the order ID. And in manage food, to the food manager, I am passing the restaurant ID and the dishes. Here also, I am passing order ID separately. Now, while creating the order, what am I doing is I am managing food and managing delivery. Ignore this for now. I am just managing these two things. Now, manage delivery manager is going to take part. Manage food manager is going to take part. Then this is where the singleton thing is done. So this is double check locking. This you're going to see in the code of all the managers, and I hope you are able to follow now. If not, you could check out the singleton design pattern code. There I have walked you through this thing in detail, that how you are feeling multi-threading if you don't have double check locking and what are the different scenarios. And if interested, you can actually join the course and you can, I will be discussing there in detail, and there I will be discussing in C++ as well as in Java. So here there is get order. Also, since the entire code is available on Git, you could actually just clone it and go through it yourself as well. Let's look at the food manager part. So again, this is again singleton and all of that. So here the main thing is that prepare food. So if we see again the singleton part, the double check locking that we just discussed in prepare food. So there is restaurant manager. I'm getting the restaurant manager, and then from there I'm getting that for this restaurant ID, which is the restaurant you give me. Now for this restaurant, I'm telling that you need to start preparing the food. Now this is notification part and all that, again not discussing. Let's look at the restaurant now. So this is the restaurant manager. Again, this is a map, that restaurant ID, and these are the restaurants. Add restaurant, get restaurant, common things, right? And if we go inside the restaurant, there is name, availability, location. There are getters, setters. But main thing it has to do is to start preparing the food. And here I have just added like a sleep, and I took care of the notification. But again, you don't need to think about all of this for now. Here, basically, restaurant is supposed to accept the order and start preparing it. So within restaurants, there are menus. Here you can see within menus, there is dishes, and within dishes, there are dish add-ons. So dish, again, dish has name, cuisine, price, this image, and then dish add-on is within the dish, correct? So you can see dish add-on as well. I'm not created CPP of this because I just wanted to show you the structure. So Obviously, there's going to be more things over here, but since it is basically a wrapper of data, for now I've just created the header files. Coming to the delivery part, this is the delivery manager. Again, there's the static instance, there is a getter, which is again static, and the main thing that we have to do is manage delivery. If we go inside manage delivery, okay, so now this is interesting. Again, in delivery manager, there is double check locking for singleton, and manage delivery is the most interesting part. So here first we get the strategy manager. The strategy manager is going to determine which matching strategy we are going to use, and it is going to return the delivery partner matching strategy that we are going to use. Again, this is an interface, but because it is returning, we have it now, right? So within this, there is this function called determine delivery partner matching strategy. Currently, we have just one matching strategy, and I have just returned location based, but on the basis of this delivery metadata, it is going to use. So let's quickly look at the strategy manager before we go ahead. So strategy manager has just the determine part. If we see this CPP, here you can see again double check locking, and here for now I've just added an output statement that based on location, weather conditions, other factors, we are setting the partner matching strategy. And if we see the partner matching strategy, which is this, here there is the function match delivery partners, and we are passing delivery metadata, and we are returning a vector of delivery partners. So as you can see, equal to 0, this is pure virtual function in C++. Basically, all the classes that are going to implement iDelivery partner matching strategy, they will have to implement this function. In our case, the example is location-based delivery partner matching strategy. Currently, again, I have just added the output. If you want to see that how the location-wise, nearest delivery partners are found, not just for Swiggy, Zomato, for Uber, Ola also, I did another separate LLD video just on quad trees. I wrote the entire code myself, explained the entire thing in detail, what is quad tree, how it can be implemented. So if interested, go check that out as well. So basically here I just went to delivery partner manager and I got the map, and whatever was the first one, I just pushed it and I returned it. For now, I've just returned the first one. Obviously, there's going to be a separate algo altogether for this. Coming back to our managed delivery. So our strategy manager decided which matching strategy we are going to use, and using that strategy, I matched the delivery partner and I got a list of delivery partners. Now I'm going to go through this, send them the notification that can you perform this delivery. They will accept it, and from there they will perform the delivery. For now, I've just added over here only. So basically, whoever is the assigned delivery partner is going to perform the delivery. So here, in order to run this, I just added some sleeps and some notifications in order to run it. So you can actually clone it. You can run the code and you can see that you will be able to see the output statements that, okay, delivery is happening. The status is this, picked up, on the way, and all of that. I've just added sleeps for now. So that was it for the video. I hope you liked. And if you have any concerning points or if you have any different opinions, let me know in the comments. I would love to discuss with you. Again, a reminder, the live LLD course is starting on 19th September. So if interested, the link is in the description, keertipurswanicourses.com. You can check out the HLD FAQ, LLD FAQ. Everything is mentioned in detail over there. But I really hope you like the video. A lot of effort has gone behind it. If you liked it, please do subscribe. Please do share with your friends. Help them also understand LLD better. And this is all completely for free. So I hope you will support me. And if there is any other system that you have in mind that you would like me to cover, please do let me know. I would love to cover on my channel. And see you next time. Bye. Thank you.